SEA today.
Welcome back everyone to A's Online Virtual Classroom. This is your boy Mr. Dre once again bringing you SEA Today, brought to you by A's Online Tutoring Services, where we count down 100 days to SEA 2021, giving you the best tips, best tricks, and the best ways to answer all questions for this year's upcoming exam. So before we get started, we have to update you. We are on our last day for week 1 mathematics, and we covered so far 38 questions. So tonight we want to get into the last 2 questions on this specimen paper. But if you haven't seen any of the previous questions done, numbers 1 to numbers 38, you're going to have to click the link up top and go back and watch those videos and come back so you'll be able to follow along up to speed. Alright, so as usual, we're gonna take our time and get over to the classroom. And today, as I said, we're continuing with specimen paper, doing numbers 39 and 40. So if you don't have your pen and paper ready, pause the video, make sure and get that. So by the time the timer starts, we will start. Alright, so let's get it. So this is the first question. It says, on the grid paper below, draw the quadrilateral with one pair of parallel sides, one line of symmetry, and the straight line that joins the points A and B as its base. So this question actually comes in multiple parts. This is the first part of it, where they're asking us to draw a quadrilateral. So what is a quadrilateral? Well, a quadrilateral is any shape that has 4 sides. That's what quad stands for. So we have 5 quadrilaterals that SEA wants us to know. So we're supposed to know them all. We have square, we have rectangle, we also have we have our rhombus, we have our parallelogram, and the last one on the list would be a trapezium. So out of these 5 quadrilaterals, we have to pick one to draw here. So we have to kind of go through and see what they're talking about. So the first thing they told us about the quadrilateral they want us to draw is that it has one pair of parallel sides. Alright? So when we go through all that we have here, we're seeing parallel means running in the same direction, 2 lines that will never meet or never touch at any point. So they're evenly spaced throughout the whole stretch of the line. So in most quadrilaterals, we have more than one parallel line, because this is parallel. In the square, it has 2. Same thing in the rectangle, it has 2 parallel lines. Same thing in the rhombus, it has 2 parallel lines. Same thing in the parallelogram, it has 2. Guess what? Parallel lines. Right? So immediately that first hint takes out all of these, because none of them have one pair of parallel lines. Alright, so this is the only option we have. So we're gonna have to draw this on our grid, but we're using A and B as its base. Alright, so let's see how best we can draw this here now. Let's get a bright color so we can see it. So this is the base, and we can come up 1, 2, 3, 4 on this side, and we can come up 1, 2, 3, 4 on this side and bring our line on top to connect it. Perfect. So just so you can see it, this will be our base, and that is a trapezium where it have one pair of parallel lines, which is one pair is this and this. These lines are parallel. They're not the same length, but they are parallel in parallel to each other. Alright, so that's the first part of the question. We're going to go on to the second part of the question here that says complete the drawing using the straight line that joins points A and B as a line of symmetry, right? And describe the completed plane shape in terms of its angles, sides, and lines of symmetry. So this part of the question now wants us to go back to the drawing and apply some other things to it. So let's see what they said. They said complete the drawing using A and B as a line of symmetry. So line of symmetry means what is on one side is mirrored or copied on the opposite side, right? So they want us to use our line AB as a line of symmetry. Let's see how close we could get to our shape. So this baseline AB would have to be a line of symmetry, and we would have to therefore copy the top part of this on the bottom side of our shape, right? That is how we're going to have to expand our drawing. And I just want to, okay, so we counted 1, 2, 3, 4 times this way. That means we have to be the same on this side. 1, 2, 3, and come down a little bit, right? So we can draw that in one time. 1, 2, 3, 4 on this side, right? And try and do the same on this side. 1, 2, 3, 4. 1, 2, 3, 4. And we just connect it up. Now line A and B is a line of symmetry. So we have the same image on top, on the bottom, and we basically have a brand new shape. It's no longer a quadrilateral, right? Quadrilateral is 4 sides. This have more than 4. So we just did the first part of the question that says to complete the drawing using AB as a line of symmetry. Now for this part here, it says describe the completed plane shape in terms of its angles, sides, and lines of symmetry. So the first thing we're going to do is look at that thing we drew and talk about its angles. Then we're going to talk about its sides. Then we're going to talk about its lines of symmetry. Right? So just put in some numbers so we can keep track of what we are doing. So let's go back and look at the angles inside of this brand new plane shape. So the angles is the where two lines meet and the space that is formed between those two lines. So in this shape, we now have a number of angles here. We have one angle here, one angle here, we have one angle here, one angle here, here, and here. So in total, the shape now has 6 angles in them. There are plenty things more you could say about these angles. You can say that, okay, let's see. So we have some obtuse angles here, no? Yeah, all obtuse angles. No angle here is less than 90 degrees. Nope. They're all obtuse angles. So there are 6 obtuse angles. An obtuse angle is an angle that is more than 90 degrees but less than 180 degrees. So we can write that in right somewhere here. Number 1, the angles. I can write it all in caps so we can see it properly. The angles of our new plane shape has 6 obtuse angles. Alright, so I started off my sentence bad. Let me just take off that. So our new plane shape has 6 obtuse angles. Alright, so that's, you can see that about the angles. Now let's take a look at the sides. So the sides now, you can see a couple of things about the sides. There are 6 sides. It's a 6-sided shape. We have 1, 2, 3, 4, 5, 6 sides. And apart from the sides, the number of sides, we have 1 pair of parallel lines. You can see that up here and to the very base here. These 2 lines are parallel to each other. And they are equal in length. So we have 1 pair of parallel equal sides, and the other sides are equal in length but they're not parallel. Right? So let's see, we can say for the sides it is a 6-sided shape with 1 pair of parallel equal sides. 1 pair of parallel equal sides. Yeah. Alright. And last but not least, I want us to mention or talk about the line of symmetry. So what I will say now, a regular polygon, a regular hexagon has more than the amount of lines of symmetry I'm about to draw, but this hexagon is not regular. Why? Because its lengths are not all the same size here. So in that case, we only have 2 lines of symmetry in this shape, which would be coming straight up the center like this, right? And of course, going along the original line of symmetry that they asked us to draw along line AB. Any other lines of symmetry going diagonal or anything like that would cause some uneven pieces on either side. So we can say there are 2 lines of symmetry. And that brings us to the end of our answer. Alright, so that is 4 marks. It takes a while to go through everything. Take your time and go back and take a look at the question. Read it a couple times and get familiar with how these questions are asked and what kind of answers they're looking for by the end of the question. Alright, so we're ready for the next one. Number 40, this is our final question. 5 students ran 60-meter sprint races at Seaview Primary School. The times students took to complete the sprint races are shown in the table below. So sprint races just means a race. You're running a race, a sprint, very fast, or try to run it fast. And this is a school event, and they took the times for the races for 5 students. 1, 2, 3, 4, 5. So if you look at the table and you analyze it, you will notice that each student ran 5 times. Sprint 1, first sprint, second sprint, third sprint, fourth sprint, fifth sprint. So you have a column that gives you the time in seconds for each student that ran in the races. The last column on the end here gives us the average. Now with maths we are doing, so this is not average as in meaning kind of okay or kind of good. Average meaning where you take the total and you divide it by the amount you added up. That's average. So in order for us to make sense out of this, we could see that the averages for each person is different, and we could take our time and read through each time, right, for each person, and get an idea of okay, who has the best average, whose average is not so good, and you can get a lot of different types of information or data from this simple table. So this is the table. We haven't seen any question yet. This is just information on the page. The question is next. They say, based on the information given in the table, state 3 reasons why an average is not a good measure to select a student to represent the school in a 60-meter race, and select a student to represent the school giving your reason. Alright, so they gave us the averages of all the students in the table, but now the question is saying to state 3 reasons why an average is not a good measure. Right? So let's take a look at this table a little bit more. And let's take a look at the averages. So Troy ran all 5 races and his average was 10.2 seconds. Right? Andy, his average was 12.0. Jesse, average was 9.8. Stacy's average was 10.1, and Chris's average was 10.2. So the question is telling us, well, average is not a good way to pick the student to represent the school. Why? So the person with the best average here is Jesse. And if we were to go by the best average, we would pick Jesse. But the question is telling us, well, average is not a good measure. So let's use Jesse as an example to say why average is not a good measure. And if you watch Jesse's times carefully, Jesse started off running really fast. Now, the smaller the number is, the faster the person ran. That's how these races, this is how it is in sprinting. So Jesse actually came first in the first race, right? However, as time went on, his times got slower and slower and slower and slower. So every single time Jesse ran, it was slower. This person does not have a consistent way of running. They actually run worse as time progresses, it seems. So I wouldn't pick Jesse because Jesse starts off good and doesn't end off so well. Alright, so I could probably mention that because Jesse ended up coming second to last in the last race by the time it was done. So he started off coming first, and then by the time the end, he was second to last. So when it comes to Jesse, the average is the fastest 1, but his times are not the best, and they get slower as the races continue. Alright, so that's Jesse. That would be one reason why I wouldn't use the average. Alright, so let's go back and take a look at somebody else. So Jesse was 9.8. So I'm seeing here two people have 10.2. And Andy has 12.0. Now Andy have the worst average, right? But Andy, as he ran, he got faster and faster and faster. Every time he ran a race, the time got much faster, right? So in a case like this, if I was to use average, then I wouldn't pick Andy. And Andy have the ability to run 9.1, which is very fast compared to everybody else. So I could use Andy in my second reason why average is not a good measure. So looking at Andy's average, it is the slowest out of all, but Andy has a great time as one very fast time in this last race. Alright, so I said looking at Andy's average, it is the slowest out of all, but Andy has a very fast time in his last race. So we would have eliminated Andy if we were going by average, when that would not have been a very smart thing to do. So looking at one more reason, so we looked at Andy and we looked at Jesse. Now let's look at somebody who is, I don't know, let's see. So Troy's races got faster as he went along, but he didn't have a good average. Well, his average wasn't the best, I should say. Stacy's average, so Stacy had some good races, but she also had some bad races as well. And Chris's times, so Chris started off running pretty fast. He came in second in the first race, but as time went on, he got very slow. So Chris's last time here is the slowest, no, not the slowest, but he would have come last in this race, and his average was still not the worst. Alright, so he ran 10 seconds, a lot, and so I could probably try and use Chris. Yeah, let's try Chris. So we could say with Chris's, with Chris's times average, sorry. It was not very bad, but his times got worse second. So with Chris's average, his average wasn't very bad. It was not very bad, but his times got slower near the end to the last race. So using average to possibly pick Chris, his average was okay, but his times were not. They really weren't the best, right? So it would not have been wise to choose Chris, in my opinion. There, right? Now that would be 3 reasons why average is not a good measure. Now they want us to say, select a student to represent the school, giving a reason. So I already know who I want to run my race for my school. You could say who you want, and based on all of these times here, I would actually choose Andy as my representative for my school. Why? Because nobody else in all the races came close to 9.1 seconds, which is the fastest time out of everybody here. The closest thing to 9.1 is not even 9.2, it's 9.3 and up. Alright, so Andy has the ability to run extremely fast, faster than anybody else in his school. Yeah? And this is why average in this case is not a good measure, because Andy could run 9.1 seconds and his average is the slowest. So I would actually choose Andy. So I would write in, I would select Andy because he has one of the fastest time out of everyone else. Actually, he doesn't have one of the fastest times. He has the fastest time out of everyone else in all the races. And that brings us to the end of the question. Let's make sure we can see everything here. Come on, fix it up nice. Perfect. So when it comes to Jesse, the average is the fastest one, but his times are not the best and they get slower as the races continued, right? Now looking at Andy's average, it is the slowest out of all, but Andy has a very fast time in his last race. With Chris's average, it was not very bad, it was kind of average, but his times got slower near the last race. And I would select Andy because he has the fastest time out of everyone else in all the races. So that brings us to the end of our week 1 for A's Online Tutoring Services SCA today. As we prepare you for SCA 2021, we are counting on 100 days. So thanks a lot for sticking with me throughout the whole video. If you haven't done it as yet, remember to subscribe and hit that like button. And please share this video with all your friends. We want as many people prepared for SCA 2021. So this is Mr. Dre. I had fun this first week. I'm looking forward to week 2 with you. Remember, SCA preparation today means you get to relax and have fun and enjoy yourself tomorrow. So thanks for watching, and I will see you tomorrow.
SEA Today.